Picking up with part 2 of our algebra review video, we're looking at scientific notation. So remember, in scientific notation, we can only have one digit in front of the decimals, and we get rid of all trailing zeros. So for number 12, 7.25 times 10 to the 7th would be adding 7 decimal places, moving the decimals 7 spots to the right, 72,500,000. 10 to the negative third, negative power, we move the decimal left. So 3.4, move that decimal 3 spots left, giving us 0.0034. In 14, we want to think about how far to move the decimal back in to get to 2.67. So it was 4 places. So 2.67 times 10 to the negative 4. And then with 15, we would have 6.54 multiplied by 10 to the 1, 2, 3, 4, 5th power. So that'd be times 10 to the 5th power. Then moving down to 16 and 17, using our properties and rules. Multiply the numbers out in front. 8 times 4 is 32. 10 to the negative 7th and 10 to the negative 5th is 10 to the negative 12th. Now remember, only one digit in front of the decimal, so this decimal had to go 1 spot left, dropping this to 10 to the negative 11th. 17, 7 divided by 4 is 1.75. 10 to the 12th divided by 10 to the 8th, 10 to the 4th. And moving down to our word problems, exponential growth or decay. So in these cases, we want to use those formulas where it's y equals c, and then 1 plus the rate in parentheses to the t power. So in 18, 850 is our initial deposit. That goes outside the parentheses. 5% interest would be 0.05 added to 1. So we'd have 1.05 in the parentheses to the t power. So then for 6 years, we would do 1.05 to the 6 multiplied by 850, giving us $1,139.08. 19, we're writing the decay model for part A. So we started with 50 grams, losing 18%. So it would be 50 times 0.82 in parentheses to the t power. After 14 days for part B, so put 14 in for T, we'd have approximately 3.11 grams. Then in 20 and 21, to know if it's growth or decay, whatever number is inside the parentheses, if it's less than 1, we have decay. More than 1, we have growth. Then for decay, we do 100 minus the percent in the parentheses, so 100 minus 83, giving us 17%. And for growth, we do the number in the parentheses as a percent, so 124 minus 100, giving us growth at 24%. Chapter 9, dealing with radicals or square roots, showing our simplification process. So a negative square root of 25 would just be a negative 5. We cannot have a negative inside the square root, so our answer would be no real numbers. For number 3, square root of 12, we can factor that to the square root of 4 times square root of 3. Square root of 4 is 2, so it would be 2 square roots of 3. Number 4, square root of 72, is the square root of 36 times the square root of 2. Square root of 36 is 6, so we'd have 6 square roots of 2. 2 times the square root of 27. Square root of 27 is the same as square root of 9 times square root of 3. So 2 times 3 is 6. We'd have 6 square roots of 3. 6 we want to multiply first, giving us square root of 90. Split that to square root of 9 and square root of 10. Final answer 3 square roots of 10. Then with 7, 8, and 9, you can see the math is laid out there for you. Not going to walk through each one of those, but the math is laid out. Let me know if you have questions on those. 10, 11, and 12, we need to solve the equations. So to undo squaring, we would square root each side. So x would be a positive or negative 7. In 11, we need to subtract the 27, divide by 3, and x squared is negative 9. Square root of negative 9 is no real numbers. And then in 12, we need to add 19 to each side, divide by 5. X squared is 36, so x would be a positive or negative 6. And then moving down to chapter 10. So dealing with our polynomial rules. So in 1 and 2, with the addition or subtraction, we're combining like terms. So in 1, we end up with 11x squared plus 3x minus 3. So we can combine the 7x squared and 4x squared. We can combine the 9x and negative 6x, and then just bring down the negative 3. In 2, after we combine like terms, we'd end up with 2n to the third plus 3n squared minus 6n minus 10. 3, 4, we want to FOIL. So first, outer, inner, last. So 3x plus 4 times x minus 5. Multiply our first terms, 3x squared. Outer, negative 15x. Inner, positive 4x. And last, negative 20. Combine like terms, and we'd have 3x squared minus 11x minus 20. Same thing here with the FOIL. Then combine, and we get 36x squared minus 25. In 5, a binomial times a trinomial, we want to distribute each part of the binomial. So first, take w times each term, then 3 times each term, giving us right here. Combine like terms, and we get our final answer, 2w to the third plus 2w squared minus 3w plus 27. And in 6, we're back to FOILing. Now, next section, factor each expression completely. So again, we're undoing the FOILing, and in ones like 7, we want to think what numbers multiply to equal a positive 24, add to be a negative 10. So x minus 6, x minus 4. In ones like 8 and 9, we can pull out the common factor first. So in 8, divide everything by 2x. And then we have 3x squared plus x minus 10, which can be factored down. So our final answer would be 2x times 3x minus 5 times x plus 2. 9, after we factor out the 5, then we can deal with the x squared plus 10x plus 25, which is a perfect square trinomial. So that's x plus 5 squared times 5. In 10, we have a difference of 2 squares. So square root of 36 is 6. Square root of 121 is 11. So 6x plus 11, 6x minus 11. Then in 11, if we have 4 different terms, we want to use the grouping approach. So group the first 2, factor out the common factor, 2x squared, and we end up with x plus 3. Second 2, factor out the negative 5, and we end up again with x plus 3. Combine what's outside the parentheses to get our first term, 2x squared minus 5, multiplied by x plus 3. And then you can see the work here on the next 3 factoring examples. Remember, with ones like 14, if we have 4 terms, you want to use grouping. And then we get to our last page of the review. Now we're solving using the zero product property. So that means if it's already factored, we just take each part and set it equal to 0. So x plus 3 equals 0, x minus 10 equals 0. Solve each for x, and x is negative 3, and x is positive 10. In 16, we have 3 parts, set each equal to 0, and x is 0, 3 halves, or negative 7/4. In 17, we have to factor first to x minus 5, x minus 6. Those both equal 0. So when we solve for x equals 5, and x equals 6. Then in 18 and 20, we need to get them equal to 0 first. So we have to undo the math on the right-hand side. So in 18, we end up with 4x to the third plus 10x squared plus 6x equals 0. Factor out the 2x. Then we factor our trinomial, and we end up with 2x times 2x plus 3 times x plus 1, each equal to 0. 19, we have 4 terms, so we had to use our grouping approach. You can see all the work there. Same with 20, we end up with 3n to the third minus 147n. After we pull out the 3n, we get a difference of 2 squares. So it'd be 3n times n plus 7 times n minus 7, giving us 3 different answers. And then in 21 and 22, we need to get them equal to 0 first. And then we can do our factoring of the common multiple out of them. Factor the trinomial on the inside. And with 21, we end up with x times 3x minus 1 times x minus 2. And in 22, after we pull out the 5y, we should have 2y minus 5 and 2y minus 5. So after going through both parts of the video and looking through the PDFs, if you still have questions on the review, please let me know before your exam date.